Just a little recap here. When we plot a distance time graph here, we can use the distance time graph to analyze the motion of an object. Okay. The manipulated variable is plotted on the bottom of the graph, the x-axis. Okay, so that's right here, of course. That's your x-axis here. And the y variable, the responding variable, okay, in this case would be the distance, it's plotted on the side of the graph, the y-axis. Okay. For a distance time graph, time is the manipulated variable. Time goes on the bottom, on the x. This is always probably for us. Time's almost always going to go there, I think 99% of the time, if not 100 for grade 10 science. And distance is going to be over here. Now, that's only for this graph here, of course. We haven't looked at all the graphs possible yet, so just be patient with that, okay? So just, for today, that's where it's going to be, okay? All right. Now, rules for plotting a graph, we talked about last day. Remember, we have to have a title, okay? So ensure the graph has a proper title, okay? It should be descriptive enough to indicate what is in the graph. Label your axes and include the units. So you'll notice, for example, I think we did a different one the other day here, but here we have time in minutes, okay? So we clearly know. Here we have the distance in miles, okay? So you'll notice the units are in brackets there. And most important, we have a title here, okay? And like I told you last day, it should be the y versus the x of something, okay? So the responding versus the manipulated, okay? Responding here, manipulated here, okay? Of a person running, a person walking, an ostrich, okay? Distance versus time for an ostrich, or something like that, ostrich running or walking or whatever, okay? All right. Oops, wrong button. There we go. Okay. Now, we talked about last day, we need a proper scale, and I kind of started to show you how to do this, okay, last day here. But basically, it looks like a little something like this here, okay. A proper scale. Each axis needs a scale that starts at 0, usually, not always, but usually, okay. And it should increase at a constant rate. So it has to be constant, okay? For example, it goes up by 5. So 0, 5, 10, 15, 20, yada, 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 okay? The scale needs to be chosen so the graph takes up a large part of the page. It might not be the entire page, but it's got to be most of the page, okay? AKA, when we draw graphs, we don't do this, okay? I have this nice big page here, and then my graph looks like that, okay? That's not good. That's really crammed together. We want this graph to be used up. So we want the line to take up, or whatever we're graphing, we want that line to take up most, okay, of the graph, if not all, okay? So basically what we're going to do is we're going to count squares, okay, or basically divide. So we have one coming up here, but we're going to have some squares here, of course, as we go across, and same thing this way, okay? And we're going to count how many squares or how many lines we have, okay? This would be 0, of course, so we kind of start here. So this would be, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say there's only 10 in this case, okay? Well, then I have 10 squares. And I take that range and divide it by, in this case, 10. And that would tell me what each one of these is worth. Okay? Maybe it's 5, maybe it's 7, maybe it's 10, I don't know. Okay? Same thing this way. Okay, so we go this way. Oops, grab a different color. 1, 2, 3, 4, 5, 6, 7. Let's say there's only 7. Well, I would take the range in this case and divide it by 7. Okay, and the range, of course, is the highest. The range is the highest minus the lowest value. Okay, quite often that lowest value is in fact 0. Okay, and we divide it by the number of squares we have. Okay, now, so here's an example here where we've kind of spread this out, and we have quite a bit of, we're going from 0 here, but you'll notice they go up evenly. 10, 20, 30, 40, 50, 60, etc., etc. 10, 20, 30, 40, 50, 60, 70. Okay? So we're spreading those out equally. Okay? All right, let me just jump ahead real quick here. Okay. Okay, all right. So, the line of best fit. Okay, is this, can somebody just verify here? Are we still in order here? Is this still okay for you guys for the notes here? Yes, no?
Yes.
Okay, thank you.
For me, I have no idea where we're at. I have 4 different sheets, but none of them match up.
Are you on lesson 3?
Yeah.
Can you see a line of best fit somewhere?
I see it now.
Okay. So, line of best fit, okay? That's exactly what it sounds like. It's a line that best fits the data, okay? When you calculate the slope, you must first draw a line of best fit, okay? So we're going to use 2 points on the line of best fit to calculate the slope. The line of the best fit should be drawn so that it shows the general trend of the dots. And it is not, and I know this is jumping a little bit ahead here, so just bear with me, we're going to come back to this. It is not a game of connected dots, okay? So if you have dots that kind of look like this, for example, we are not going to do this. Not going to do this, okay? Like, we're not doing that, okay? So what we want to do instead is we want to find a general trend of the data, if you want to think of it that way, okay? If some data points will fall on the line, try and draw a line so that the same number of points fall off it on each side. So, for example, if I had this data here, I would try and draw a straight line maybe through these because I have, look, a point here and a point there, okay? And I have a point here and I have a point there. So I'm trying to kind of split the points up. So I'm trying to draw through some points, but I'm trying to get a general idea of what this line will represent, or these points will represent here, with what we call a line of best fit. Okay? So again, we're not connecting the dots. Okay? Now, let's see what we got here. Okay, I'm going to skip that for right now. Now, I think we have a, is this correct? Do we have the example 1 there? Is that what's next? Somebody?
Yeah.
Okay. And this was the jet, I believe, yes?
Yep.
Okay, thank you. So, let's go ahead and take a look at our jet here. And in fact, let's see. I'm going to try and get rid of this. Yeah, here we go. I just got to figure out how to get rid of this. Yeah, there we go. Okay, so I believe this is what your graph looks like here, right? Correct? You got a little piece of graph paper there. And I'm just going to erase a little bit more here. Apologies. Sorry. Does this look good so far? Yes? Somebody? So you have a little graph there, correct? A paper there.
Yeah.
Okay. And I believe this one should have the same stuff on it here as well. Okay. So we should have basically something looks like this. Okay. Now, can I get someone to do me a favor here? What is this data representing here? This is example 1. Okay, on your sheet there. What does it say? What is the data of? Anyone? Quickly.
Time and distance.
For what? For what, somebody?
Jet.
Thank you. So we're going to, of course, we talked about this. We're going to make a title for this. Yes? So actually, just let me move this out of the way here. Oops. Oh, maybe I'm not, oh, there we go. Okay. So we need to make a title for this. So the first things first, we're going to call this what? distance, okay, so go ahead and do this with me here, versus time of a jet. Okay? We need to label the axes, and again, remember, it's always responding, okay, versus manipulated. Manipulated is the time that's going to go on the bottom of a jet. Okay, distance is going to go on the side. So right here, I'm going to write down distance, and you don't have to write it down sideways. I just don't have a lot of room. And the distance, I believe, is in kilometers. Is that correct, somebody, please?
Meters.
Oh, is it? Okay, thank you. And, of course, down here, we're going to put time. And this is measured in, if I'm not mistaken, seconds. Is that correct? Yeah. Should be, yeah? Someone?
Yeah.
Thank you. Okay, so, perfect. Now, like we talked about last day, they give us basically this graph, and we're trying to plot these points here. So we want to plot these points to kind of get an idea what this graph's going to look like. Well, again, I think it starts at 0. Let's look at the time part first, okay? So I wouldn't probably do this on the graph here, of course. I'd probably do this off to the side somewhere, but I'm just going to go ahead and throw another sheet in here. But for the time, okay, under the time, I think it says 0 and it goes up to 5. Is that correct? Somebody? On your little chart there? Okay. So again, we would count the squares. Okay. So we have what? I'm going to get rid of these right away here, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, which I know we did last day. So there's 20 squares, and there's actually 20 going up as well, so just keep that in mind. But I'm going to take the range, okay, 0 to 5. So 5 minus 0 is 5, and divide it by 20 squares. Okay. I take the range and I divide it by the number of squares. Don't do the opposite, okay? So in this case here, 5 divided by 20, like I said last day, is about a quarter, or 0.25, okay? So what that tells you on your graph now, okay, is everyone caught up here so far? Help, anyone? Okay. So what that tells you is that each one of these squares, that's 0.25. There's 0.50, another 0.25, 0.25, 0.25, and so on and so on. Now, I'm not going to write down all of them because really, which ones am I interested in? I'm interested in 0, okay? Now, this would be 0.25, this is 0.50, 0.75, this is 1, okay? So I'm going to get rid of these because I really don't need to plot anything there. Like if we had gone up by quarters, that's fine, we could do that. So it says here basically every fourth one of these is going to be another number. So this would be 1.25, 1.50, 1.75. There's 2. Okay? 2.3, 25, 50, 75, 4, 25, 50, 75, 5. Okay? Notice, I'm going to just get rid of these dots in between here just because that's what I was just kind of showing you here. Okay, notice now we've used the entire bottom portion of this graph. That's awesome, okay? And this would be 5 here, of course. So that's great. That's what we need to do, okay? That's what we want to have happen. Again, you don't have to label exactly every square. Which ones do you label? Well, the ones that make sense, okay? We have the data that we have there is like 0 seconds is this. 1 is this, 2 is this, 3 is this, 4 is this, 5 is this, okay? That's what we want to do, okay? Now we go back to here. If we talked about the distance, okay? The distance goes from 0 to, help me out here, is it 2,500 somebody meters? Is that correct? In the graph, in the table there?
Yeah.
Thank you. So we're going to take our 2,500 minus 0, divided by 20. Okay, there's 20 squares along the side there, and that gives me 125. So basically now they're saying each square is 125. Okay, good. So, okay, That's from the table again. I take the range, 2,500 divided by 20, it's 125. Okay? That means every square going this way, that's 125. That's another 125. That's another 125. That's another 100, etc., etc. Now, can you label every square? Sure you can. The numbers are going to get kind of tiny in this case. Do we need to label every square? Probably not. Okay, you know, you can kind of look at the data and see if it makes sense or not. But look, I could say this is 125. This would be what? 250, yes? Okay, that's 375. That should be what? 500, yes? Okay, so each square is still 125, but I'm not labeling every square just because I don't need to, okay? What's going to happen is I'm going to have 5 million numbers on here, well, actually 20 numbers, and I probably don't need to do that, okay? So you can kind of see the pattern. Every square is 125. Every 2 squares would be what? 250, yes? So here, this would be 750. This would be 1,000. This would be what? 1,250. Just can't screw this up though. This is 1,500. Okay. This would be 1,750 here. 1,750. This would be what? 2,000. This would be 2,250. And this should be what? 2,500, which I believe is our highest number on this graph. Okay. Perfect. Perfect. Okay, so I want you to go ahead and do this, please. Now, we need to plot some points. Okay, and again, this I can't really help you with this at home. Okay, so you're kind of on your own here. You're going to have to find those points. Okay, and start plotting them. Yes. So let me just find those points here. I know for a fact that, and I'm going to use a pretty little blue here, 0, 0, sorry, that is a point on this graph. Okay, what's 1, somebody? Can somebody tell me there, please? 1 and what?
500.
1 and 500? Perfect. There's 1, and there's 500. So right there. Okay, what's the next one? 2 and... Somebody? Quickly. 950?
Yeah.
Okay. So now this is where it gets a little tricky here. 2 is obviously right here, but 950, well, okay. We said this was what? This would be, this right here is about halfway in between, obviously, right? That's another 125. Remember, every square is 125. So that would be what? 875? Okay. So if that was 875 and this is 1,000, okay, you know, we're kind of looking at probably a little closer to the 1,000 than we're you know, because halfway in between, what's halfway in between? I'm just gonna, you don't have to write this down, but this would be 875 here, right? So 950, let's see, it'd be about 75 extra than here, okay? And each square is that. So it'd probably be around here somewhere, I'm thinking. So 2, right here, we're gonna go up, and I'd say it's probably gonna be right about here somewhere. It's gonna be a little bit below that line, obviously. It's not 1,000. What's 3, somebody? Quickly.
1,400.
1,400. Okay. So 3 and 1,400. Well, of course, I'm going to say that that's a little bit below. Let's see. Remember, this is 1,250 here. That's 1,500. This actually right here, this line right here is what? 125, so that's what? Yeah, it's 1,375 right here, isn't it? That's 1,375 line. Again, you don't have to write that in there. I'm just saying that's 1,375. And you said, sorry, what, 1,400? Is that correct? Yes? No?
Yeah.
Okay, so 1400. I'm going to go right about, oops, sorry. That turned into be not a dot at all. 1400. I'd say it's probably just going to be slightly above that line. Okay. Now it's not going to be exact, and that's okay. That's not the end of the world. Okay. 4 is what again? Sorry, 2050. Does that sound right, somebody?
Yeah.
Thank you. So 2050. Oh geez. Okay. Well, that's only about 50 above 2000, of course. So I'd go, I don't know, about there somewhere, maybe. Okay. 4 in 2050. And I know the last one is 5 in 2500, yes? And 2500, of course, will fall nicely right there. Okay. And look, I definitely used all my graph paper here, haven't I? And that's awesome. Okay. All right. I'll just let you kind of catch up here a bit. Is there any questions so far, anyone? Ask, because you're going to have to, we're going to have a lot of graphing this unit, so we need to know what's going on here. Okay. Now, okay, we talked a little bit about the line of best fit. I'm just going to, just give me 1 second here. I'm going to, yeah. Okay, so I'm actually going to jump to this graph here. Okay, actually, you know what? No, I'm not. I'll show you this at the end here. But so sorry. I guess here was my numbers right here. I had them. I knew I had them, but I just didn't know where. I should have went a little farther. Okay, so here I've graphed my graph, and now what I need to do is get a ruler, okay, or something that's straight, and I need to find what we call the line of best fit. What line is going to go through maybe as many points as I can get it to go through, yet still, okay, represent the data that I have here. Well, look, here's what I'm going to do. I'm going to try this. I forget now. I apologize. But I did, obviously I did this on the last one here, so let me just try this here. Okay, I'm going to draw a line. Let's see. I'm going to try this. Nope. That's not it. Let me try this one more time here. Oh, there we go. Okay. Now, bear with me for a second here while I draw my line of best fit. Ah, shoot. Let's see. Okay. I kind of forget how to do this, I'm not going to lie. Does that make a difference? I don't know. Nope. Oh, stop that. Oh. Okay, I got to undo a bunch of stuff here. Oh, there we go. I think this is what I want. Yep. Perfect. All right. And perfect. Okay. There we go. Okay. Now, just let me rearrange this. Oh, that's pretty good. Okay. So here's a line. You might say, well, I just connected. Now, just wait. Don't do this yet. Sorry. But look, I've connected this line here. Okay. And you might say, well, you just connected the first point and the last point. I kind of did. Okay. Now, is that right or wrong? It's not really right. We shouldn't just connect the first point and the last point, okay, like I did here. So in that case there, what do I need to do here? How do I get this line of best fit? And again, the answer is, well, this is kind of my starting point. I wouldn't draw that per se, but we have to kind of look at how well does it represent these points, okay? So, okay, well, let's see here. Hopefully this is going to work on me here. I'm just going to check something. Yeah, okay. So you might say, okay, how good is this line of best fit? Well, notice, okay, right now, and maybe this is my fault a little bit here. Maybe I can get that right there, okay. Yeah, that's probably a little bit better there. Okay, and that looks pretty good there. Now, you'll notice that this line, my dot's right about, should be right about there. Okay. Now you'll notice that, yeah, it goes around this point here, so that's good. Okay. You'll also notice, hey, look, it goes through that point there too. Well, that's a win. But you'll notice it does not quite go through this point right here. I'll use maybe a different color for this one. That's okay, all right? But it also doesn't go through this point, and that's okay too. And it doesn't go quite match up with this point, but you'll notice it does match up with this point here, okay? Sorry, my recording thing is in the way. There we go. It does match up with that, okay? So how good is this line of best fit? Well, it's not bad, actually, all things considering, okay? We have 3 points that are on the line, and we have kind of 3 points that are off the line, okay? But we also have to take into consideration here that, you know, first of all, this is barely off the line. This is a little bit bigger off the line, yes? And then this is kind of barely off the line here, but it's above the line, you'll notice, okay? So kind of what I'm thinking here is this. This and this point kind of cancel each other out. One's a little bit too high, one's a little bit too low. Okay? Okay. So they kind of cancel each other out, so that's not bad. Okay? Now, the only thing that's kind of doesn't really cancel each other out is kind of this guy right here. He's kind of the issue, isn't he? Like, he's kind of below the line. And I got nothing to really offset him. If I had another point right here, for example, let's just say, for example, there was another set of data, and I put a point, let's say, right about here somewhere. Okay, just pretend for a second. I'd say, you know what, that's a pretty damn good line of best fit. Okay, but I don't have that point, unfortunately. So technically, okay, I would say that this is not quite the line of best fit. What I might want to do is I might want to just perhaps suck this line down, maybe perhaps just a little bit, okay, to kind of offset this difference there, okay? So I might want to do that, and like I said, I would just kind of suck the line down a little bit, okay? Now, unfortunately, I just erased my line somehow, I don't know, okay? But you might want to consider just kind of sucking that down a little bit. It's not going to let me do that, but that might be something that you might want to consider. Okay, I guess the other option I could have is, you know, maybe just kind of bring that like that kind of thing, and then bring this down just a bit like so. Okay, but you're going to notice when you do that that some of those points that we had on the line before are not going to be on the line anymore. Okay, so we just kind of have to kind of play around with it a little bit, or what do you think is going to be the best idea? Okay, now, again, what's going on here is, you know, I think the first point's really good. I think the last point's very good. The ones in the middle, some are okay, some are close, but they're not quite on the line, of course, and, you know, it is what it is kind of thing. Okay, so the idea is to kind of get the line through as many points as possible and try and split up the rest somewhat equally, okay? And, you know, maybe we just need to be happy with, where was my line before? I think it was right there. Maybe we just need to be happy in this case with this line, okay? So, like I said, in the big scheme of things here, it's not bad, okay? It's not bad. This one here is a little bit below, this one's a little bit above. So again, those would cancel out. The only issue I have is kind of this one right here, and sometimes, you know what, that's what's going to happen, and good enough. Okay, so be it, kind of thing. All right. So, is that good, everybody? So far? Questions, anyone? Questions? Speak up. Okay. All right. So has everyone got their line of best fit? Are we good there? Yes? No? Speak up. Everyone's good? Kate, do you have a line of best fit?
Yes.
Cade, you got a line of best fit? Uh-oh. Noah, you got a line of best fit?
Yeah.
Perfect. All right, we're moving on then, unless somebody speaks up. Now, the next part, I believe, okay, is we get to kind of, well, we got this part here. We don't need that. Okay, so here's this line of best fit. Okay, kind of similar to what I had, I guess. Yeah, pretty close, I think. Okay, this was plotted using a computer, of course, and then they kind of just drew a line of best fit, something like this here. Okay. Now, the next thing we need to talk about, okay, is the slope of the graph. Is this still lesson 1? Is that correct? Somebody? We're good here?
Yeah.
Okay. Is this the next thing in your notes, by the way?
Yeah.
Thank you. Okay. So, I know this has kind of been a long lesson here, and I apologize for that. I seem to be talking, and especially I especially noticed that now it's been 31 minutes, so that timer is probably a good thing for me, actually. But we have one last thing that we kind of need to talk about with graphs here, and that is something called the slope. Okay, and the slope of a graph, okay, basically indicates, in this case, yes, it indicates the speed of the object, okay? Speed. And the reason is the slope. Can someone tell me, when I say slope, what does that mean to you? Do you guys remember doing the slope at some point? Anyone? You can see the little triangle down here. What do you remember about slope, anyone? I'm sure you must have done slope at some point here. Anyone? Come on, talk to me, people. Slope. Who's never heard of the slope before? Oh boy. Okay, slope represents what? What if I said rise? What's the other word that you would think of? Someone, quickly, hopefully.
Run.
Yes. So the slope is the rise over the run, right? Okay, so slope, you're going to have to write some stuff down here, people. Rise over the run. Okay, and the rise basically implies, okay, by the way, the change in y. Okay, so that's basically, if I look at my graph here, that's this right here. The change in the y values over the change in the x values. And this would be called the run. Okay, change in y over change in x. Sometimes we talk about, okay, y2 minus y1, x2 minus x1. Who has never seen this before? Speak up. I'm not even going to know who you are, just so I know what's going on here. It's okay if you haven't, because I don't know what you guys know and what you don't know from grade 9. Okay? Down here, you'll see our little speed formula here, yes? Distance over time. Well, look, the distance, the change in the distance is right here, right? Look, this is the change in the distance right here, and this is the change in the time. So when we talk about the change in distance over the change in time, we're talking about the rise over the run. What happens when we divide the rise by the run? We get the speed, okay? In fact, it'd be the average speed, okay? It'd be the average speed here, okay? So the slope of the graph indicates the speed of the object, okay? So does that make sense? Is there any questions here? Rise over the run. Okay? Now, I do also want to mention here, okay, that we have something called coordinates. Do you guys remember coordinates? So right here, okay, that's a point on the graph. That would be called something like, for example, that would have an x and a y coordinate, or x2 and y2, for example. I picked those. It could have been x1 and y1. I don't really care, okay? But that's kind of what I'm referring to up here, if that makes sense, okay? Here's another coordinate right here, okay? And I would call that one maybe x1 and y1, okay? Or whatever, okay? And if I wanted to find the slope, which is this, basically how tilted is that line, or in this case, how fast is this going, or how slow is this going, that is referred to as the slope, the rise over the run, okay? And that's where that little triangle comes from. It has to be a right triangle, of course, as well, okay? But those are what we call coordinates, and we need to use those coordinates, okay, to calculate perhaps maybe the slope, right, which we're going to do here right away. Is that good? Is there any questions before I go to the next slide here? Okay. All right. So I think this is our next example. Is that correct? Yes?
Yeah.
Thank you. Now, so we're going to do a little practice with this, and then we're going to get back to our big graph here that we did before. So, determine the slope of the graph from 0 to 2 seconds, and then what does this value of the slope represent? Very common question on quizzes / tests, okay? So let's find 0 to 2 seconds here. So the first thing I'd say is let's maybe even color that in here. Here's 0 to 2. They're talking about this from there to there, yes? Okay, that segment of the line only, okay? So here's what I would suggest doing. If you're not sure what's going on here, okay, if you've never heard of slope before, we need to probably come up with, to calculate the slope, we're going to talk about the rise, always the rise over the run, okay? In this case, look, we have the distance over the time. Distance over the time. And the distance over the time, of course, in this case, we know from last day that it is the speed, yes? So I can tell you right now, what does this value of the slope represent? It represents speed, or average, actually, speed. Okay, from 0 to 2 seconds. Now, how are we going to calculate the slope? And, okay, some of you would be able to do this just by looking at it, and that's fine. But sometimes it doesn't work out very nicely like this as well. Some of you guys would say, okay, what's the rise? Okay, so maybe you're not sure what we're doing here, but we're going to make a little triangle here, like so, okay? What's the rise? This is the rise, and this is the run. And if you don't understand this, that's okay. We're going to get to another way to solve this. What is the rise? How much is this right here? Somebody tell me, please. How much is that? Quickly. How much did I go up?
10 meters.
Thank you. So we go up 10 meters, yes? So basically 0 to 10 here, so that's 10 meters. Notice I'm going to put in units here as well. And this is super important when we're talking about slopes, because when we get a final answer, it's going to tell you what it represents. Okay, and I can't stress that enough. Today we're doing speed, that's all we know. But down the road, after 5 graphs, different graphs, these units are going to tell you, oh, okay, I'm talking about speed. I'm talking about acceleration. I'm talking about displacement, whatever, okay? Now, how far is this section here? What's the run, somebody? How long is that? Quickly. Gonna run out of time for homework here. Thank you. 2 seconds. Okay? Look, 10 meters divided by 2 seconds. 2 significant digits. I get 5 meters per second. What is meters per second a measurement of? It is a measurement of speed. That's how I know this. Okay? It represents speed. Okay? Now, if you don't understand what I just did, that's okay. I'm going to show you another way to do this. That was, for the most part, I would say, yeah, we could probably do that system with these points here or this graph. That's okay. Now, I'm going to show you something different here. Okay? If you're not sure how to calculate speed, watch. Okay? I'm going to pick 2 points on the line. I'm going to pick that one and that one. Okay, like I did before, from 0 to 2. Okay? Could you pick, for example, by the way, I got a question for you. What if I didn't want to pick 0, 0? What if I wanted to pick this point here? Can I do that? Somebody. Is that an option?
No.
Why?
It's not on a line.
It's not on a square kind of thing?
Yeah.
Okay. Well, I would say I kind of agree with you and I kind of disagree with you. I would agree that it's going to be very hard to determine what that point is, right? Is that what you're saying?
Yeah.
Yeah. However, okay, let's say I could determine what that point is. Is this slope, would that give me the same slope? Let me ask you that now. If I could find that point, would that give me the same slope? What do you think, somebody? Is this slope here the same as this slope here? What do you think? Yes or no, somebody? Quickly.
No.
It is. Okay? So I can pick this point and this point. They're on this line. I could pick this point right here. That slope has to be the same as this slope because it's a straight line. Okay? So it doesn't matter where, okay, I pick 2 points on this line, it's going to give me the same slope. Now, here's my next question. What if I picked, and this might not be as obvious here for you guys, what if I pick this point here and now this point here? Is that going to give me the same slope? Yes or no?
No.
No. Okay? Because look, a straight line between 2 points is going to be right here, yes? Does that represent the 2 lines that I have there, basically? No. Okay? So I can't do that. If I wanted to do this section here, for example, I might have to go from there to there, yes? Or even there to there would be the same thing as this here. That's all the same line. That's okay. I'm not sure exactly. I think this line is actually continued here. That's supposed to be straight. This would be a straight line. I could pick any 2 points on there. Okay? So it doesn't matter kind of where you pick them as long as they're on the same line. This is the same line here. So I could pick this one and I could pick this one. But I don't really know what this point is right here. It's a little hard to tell. I do know what it is, but that's just because it's on the straight line here. But it would probably make most sense from 0 to 2 here, okay? Because I actually know those 2 points, for sure, okay? But again, you can pick any 2 points on that line. I guess I'll call it a line segment, okay? So I'm going to label these 2 points. What are the coordinates of this point right here? This is called x, y, 2.0, and 10. Do you guys understand? 2.0 and 10. That's the point right there. Okay? So that's my coordinate of that point. This one right here is called 0 and 0. Okay? 0 and 0. Good? Questions, anyone? If you struggle with slope, maybe that's what you need to do. And at times, I'm definitely going to tell you that's what you should do. Okay? So, how do we do this? Again, we label some points here. Usually we kind of like to label, the bigger numbers, x2 and y2 kind of thing. So x2, y2. This is not x squared or y squared. This is just labeling x1 and y1. Okay? And basically over here, I'm going to say this. It's the change in y over the change in x, or y2 minus y1. So the change in the y's over the change in the x's. That is the rise, the change in the y's over the change in the x's, yes? Okay? So this is 10 minus 0, include units. 10 minus 0, here's y2, here's y1. 10 minus 0, 2 minus 0. And that's in seconds. Okay? So I get what? 10 meters over 2.0 seconds, and that is 5 meters per second. Final answer. Okay, just like it was up here. Now you might say, well, I'm not doing all that work. That's stupid. Well, you got to do some work somewhere, and if you don't understand what the rise and the run looks like, okay, then you might have to pick some coordinates. And it's not always going to be all nice and square like this stuff here. You have to understand how to do coordinates, of course, as well. Okay, is there any questions on any of this here? I'm almost done. Questions, anyone? Yes, no? Okay. All right. So, next. Okay. Is this the, okay, same section here now. So now look, we got to go from 2 to 4 seconds, yes? So here's 2, and here's 4. Okay, now I know that this line doesn't look straight, but it technically is, and I don't know if yours looks straight or not. I hope it does, but that should be a straight line. If it's not, I apologize. It's just the way that the lines look, but that is a straight line. If it wasn't a straight line, we're still expect to go from 2 to 4, okay? So we have to kind of assume that it is for right now. So again, how are we going to do this? Well, we talk about the slope being the rise over the run. Now, I will give you both ways again here. If you want to talk about the rise, we have to make a triangle here, right? Boom, boom, like so. How much is this? This is the rise. Well, you're going from what? 30, this is the 30 point here, to 10, yes? So 30 to 10, 30 to 10 is 20, or basically 20 meters, yes? So this is going from 10 here up to 30. So that's a 20 meters here. And what is this section right here? Well, it's going from 4 to 2. So that is what? 2 seconds here. 2 seconds. Divide the 2. We get 10 meters per second. Okay. Again, 2 significant digits. Okay. So 10 meters per second. Is that good, everybody? That is the slope, aka the average speed from 2 to 4. So what's happened here, you'll notice we've gotten a little steeper line here. Okay, it's kind of more upright. So he's actually picked up speed here now from 2 to 4 seconds, yes? Okay. If you want to do coordinates, fine. Let's do some coordinates here. Okay, again, right there. This is the coordinate what? 4. 4 and what is it? 30. Okay, and this is the coordinate 2 and 10. Okay, so these are the y's, and these are the x's, and we're going to subtract them. So over here, I'm going to say what v or the slope or whatever is what? 30 minus 10 meters. Okay, so that's the y2, and that's the y1, y2 minus y1, and here's my x2, and here's my x1. Okay, and there's my 4 minus 2.0 seconds. And you have to be careful when you enter this on your calculator. You want to probably get the top part done first, 20 meters over 2 seconds, or 10 meters per second. Okay? Good? Questions, anyone? And I think we have one more section here, is that correct? Okay. Oopsies. Let's see. Did we have to do, help me out here, somebody. I thought we were going to do this part right here. Is that true or no? Do we have to do that part or no? From 4 to 6? Anyone? Hello? Do we have to do that part? Yes or no?